Welcome back, developers. In our last video, we successfully got our character running left and right across the screen. But right now, if we walk off the edge of our platform, we just fall straight down. A platformer isn't a platformer without jumping. And today, we're going to apply core programming logic and techniques that are used in building games to launch our character into the air. So let's open up our player controller script and get to work. By the end of this video, you should learn how to use the Input.GetButtonDown to capture single key presses, how to use an if statement to implement flow control, how to apply math and physics to rb.linearVelocity for vertical movement, and how to identify and understand the infinite jump logic bug. Inside our update function, right below where we wrote the code to flip our sprite, we need to make a couple of lines and then tell the game to listen for the spacebar. To do this, we're going to apply very common programming statements to implement flow control. We're going to use an if statement. Go ahead and type if and then in parentheses Input.GetButtonDown, add more parentheses and some quotation marks, and then write jump with a capital J. And then put a set of curly braces below it. Unity's classic input manager automatically links the word jump to the spacebar on your keyboard, so we don't even have to look for the specific key code. Notice we used GetButtonDown. This means the code inside the curly braces will only trigger exactly once the moment the key is pressed down, rather than continuously firing while you hold it. So what happens when the spacebar is pressed? We need to push the character up. We will demonstrate the use of mathematics and physics to evaluate behavior in an existing game by changing our rigid body's velocity again. And we do this by putting this line inside our curly braces. RB, which is what we named our rigid body 2D up in the variables, .linear velocity equals new vector 2, and then inside parentheses rb.linearVelocity.x, comma, jump force. So let's break down this logic. We're setting a new speed for our physics body. For the x-axis, which is left and right, we don't want to interrupt the running, so we just tell it to keep its current x speed by typing this rb.linearVelocity.x. But for the y-axis, the up and down, we replace its current speed with our jump force variable that we set up a couple videos ago. Make sure you save your script. We're going to go ahead and jump back into Unity and let it compile. Once it's done compiling, we're going to hit play and press the spacebar and see what happens. So we didn't break our left and right code, so that works. And we press the spacebar, and awesome, we have liftoff. Our character jumps perfectly. But wait. Try pressing the spacebar really fast while you're in the air. Oh no, we've turned this into Flappy Bird and flown right off the screen. This is the very first major logic bug. Remember, computers are literal. They're only going to do exactly what you tell them to do. We told the computer, if the spacebar is pressed, then jump. We never told the computer to check if the character is actually touching the ground first. So, even though we have a bug, you successfully added vertical physics to your game today, and that is a huge step. Make sure you save your scene, because in the next video we're going to fix our infinite jump glitch. We will learn how to use a technique called ray casting, or an overlap box, to draw an invisible sensor under our character's feet to detect the floor. Keep learning, keep building. I'll see you in the next video.